me tell you what is an integral transform. An integral transform is of the form integral some value here. You can say a to b k of s comma t into f of t dt. This is the expression. Okay, and this will be equal to f of s, and this f of s is your integral transform of has been obtained by f of t. It is a definite integral. You can see a to b. Okay, this portion we are calling it as the kernel of the transformation. Okay, kernel of this transformation, and yes, we are calling it as a parameter. Your Laplace transform, that is, you denote it by L of f of t, which is equal to f of s, which is equal to, so the limits are 0 to infinity. 0 to infinity. Here the kernel will be e power minus st f of t dt. Let me write it properly. So this is the Laplace transform. What is happening here? Limits are changing from 0 to t. See, therefore, the definition of Laplace transform comes like this. Let f of t be defined for t greater than 0. Because you see, the function must be, f of t must be defined in the limits 0 to infinity. Had it been minus infinity to plus infinity, would have given stated like this: f of t defined for all values of t lying between 0 minus infinity to plus infinity. But the limit is only from 0 to infinity. We are defining it as t greater than 0. The function would have been defined. Okay. So provided this integral must exist. This integral, comma, if the integral exists, okay, let f of t be defined for t greater than 0. And this integral, if it exists, then we are calling it as Laplace transform of the function f of t, and we denote it by either f of s or L of f of t. So this is what the definition is all about. Okay, here in this place, during Laplace transform, s is a parameter, s is something greater than 0, okay, and or greater than some specific value according to the, this is 0 to infinity. One second, I'll just clearly write. What are they? Number 1, L of 1 is equal to 1 by s. How? Let us see. L of 1, according to the definition, 0 to infinity e power minus st, f of t place we have to replace by 1 into dt, okay, which is equal to e power minus st within divided by minus s, and within the limits 0 to infinity. When you put infinity is equal to, put s is equal s, you have to force s to be positive, otherwise the trouble will arise. Okay, when you put t is equal to infinity, 1 by infinity आ जाएगा तो 0 हो जाएगा, then minus into minus plus, so totally 1 by s is coming. Okay, so this is how you will be evaluating what is L of 1. Next I pass on to second, L of t power n. So for finding out L of t power n, either you can call it as n factorial by s power n plus 1, or it is equal to gamma n plus 1 divided by s power n plus 1, depending on nature of n. Okay, n is an integer, we can write it as n factorial by s power n plus 1. The non-integer, then we can represent in this fashion. So how we can go about this problem? Let us see one by one. Okay, so L of t power n is equal to integral 0 to infinity e power minus st t power n dt, correct? So put st is equal to u, okay, so that t will be u by s and dt will be du by s. So the limits will be what? At t is equal to 0, u will be 0, t is equal to infinity, u is equal to infinity, the limit integrals are same, e power minus u, and this is what, t is equal to u by s, so u power n, and du upon s, so totally 1 by s power n plus 1 will come outside. Okay, so this is 1 by s power n plus 1 into this expression. If you can recall, it is nothing but gamma n plus 1. Do you remember gamma n is equal to what? Integral 0 to infinity e power minus t power n plus 1. This is n minus 1. Okay, so it is coming out to be this expression. So L of t power n is equal to gamma n plus 1. Moreover, when n is an integer, you can write n gamma n plus 1 is equal to what? N factorial. Now there is a formula. Therefore, you can write it as s power n plus 1. This is how you are able to solve this problem. Okay. Similarly, next third identity is L of e power at is equal to integral 0 to infinity minus st e power at dt, which is equal to integral e power minus s minus a into t dt, and it is e power minus s minus a into t upon, what will you get, s minus a within the limits 0 to infinity. So when you are providing here infinity, you should ensure that s minus a should be greater than 0 or s should be strictly greater than a. Then only you can apply the infinity. Thereby first term will be 0. Second, at a lower limit, it will become 1 upon s minus a. Correct? So this is the expression for L of e power at. Similarly, you can find out the fourth one, that is L of cos at. Cos at, I am writing cos at, which is equal to cos at के लिए you can write it as L of e power at plus e power minus at upon 2. And of course here we apply some linearity property, which I will discuss a little later. So we can split and write like this. This is 1 by 2 into L of e power at plus L of e power minus at. This will be half into L of e power at के लिए 1 by s minus a plus 1 by s plus a. And of course here this is half into, you will be getting s plus a minus a gets cancelled. So it will be 2s upon s square minus a square, 2 to cancel. Here you have to impose the condition that this s square should be s square minus a square should be positive, that is s square should be greater than a square. So finally outcome over here will be s upon s square minus a square. So similarly you can find out the formula for L of sin at, which will be coming out to be a upon s square minus a square. This you can prove it yourself. And the sixth one, L of cos at will be coming out to be s upon s square plus a square. So you may ask how it is coming. Basically, you can write here LHS is equal to, this is the real part of L of real part of e power iat, you can write, correct? Which is equal to real part, you can take it outside. This is 1 upon L of e power iat is s minus iat, you can write, correct? So further you can write it like this. You can conjugate, you can find out. Then s plus iat upon s plus iat you can write. So this denominator portion will become s square plus a square, and the numerator this is s plus ia. Therefore this is going to be s upon s square plus a square. So this is how this formula can be established. And the seventh one will be L of sin at. So if you take the imaginary part as done, you will be getting what? A upon s square plus a square. Here it should be a positive quantity. You have to impose this condition for both these formulas. Okay, these are the certain basic important formulas which we come across. Just revisit once again what all we have established. L of 1 is equal to 1 by s. L of t power n is equal to n factorial by s power n plus 1, or gamma n plus 1 by s n plus 1. Then L of at is equal to 1 upon s minus a. And similarly minus at, if you would have taken, then it would have been 1 by s plus a. Cos h at will be s upon s square minus s square. Sin at is equal to a upon s square minus s square. And this will be equal to this much. you are getting this formula. So only thing I would like to tell about this particular topic is that it is if I just jump onto the properties. Okay, properties, first of all, first property is linearity property. So what we do is, let us assume L of f of t is equal to f of s, and L of g of t is equal to g of s. Then this property says L of alpha times f of t plus beta times g of t will be equal to alpha times f of s plus beta times g of s. So this is what we have to prove. Okay, how we are going to give the proof? Just listen. So I take LHS. So L of something, just blindly use the formula e power minus st. In place of f of t, I have alpha f of t plus beta g of t. Substitute, and then you will be getting, since integral follows the linearity property, you can split and write like this: 0 to infinity e power minus st f of t dt plus beta times 0 to infinity e power minus st g of t dt. So alpha times, what is this? This is nothing but L of f of t, and beta times, this is nothing but L of g of t, and which is nothing but alpha times f of s plus beta times g of s, because we have assumed in the beginning this quantity is equal to f of s, this is g of s, which is nothing but RHS. So this is how you prove this property, linearity property. Some of the problems related to linearity property also I leave it to you, because these are basic things, and you can do it on your own. Okay, if there is any doubt, you can ask me. The second property, I am passing on to change of scale property. Here again we presume first L of f of t is equal to f of s. Okay, then L of f of a t is equal to 1 by a f of s by a. So this is what we have to prove. So the proof goes like this. Let me take LHS. LHS is equal to integral 0 to infinity e power minus st. In the place of f of t, I have f of at. So when you start like this, automatically you will end up. Let me take u is equal to at. Du will be a into dt. Okay. So limits remain as it is. So integral 0 to infinity e power minus s into t. T is equal to u by a. So I can write it as s by a times u and f of u, and dt is equal to what? Du upon a. So that 1 by a, I'll keep it outside. Now look at here. S by a, you can call it as s dash. Then it will be f of s dash. So this is 1 by a into f of s by a. Because in the place of s, we have s by a here. So which is nothing but your RHS. So this simple is your Laplace transform. Absolutely no trouble at all. And here you can see certain problems of your own choice. Now I pass on to first shifting theorem. Third property, first shifting theorem. So the first shifting theorem, again we'll assume let of f of L of f of t is equal to f of s. Then what you will be getting? L of e power at f of t will be equal to f of s minus a. This is a very important theorem. Sometimes you may be asked, state and prove shifting theorem. Then you can write. There are two shifting theorems. Are the second shifting theorem is also there. So what is the proof over here? Here LHS I am taking. See, simply you have to do only one thing. Write LHS, then you will end up with the answer. You see, LHS, L means integral 0 to infinity e power minus st. Whatever there inside, you replace it by its value e power at f of t ke jagah e power at f of t is there, and then dt. This will be equal to integral 0 to infinity e power minus s minus a into t f of t dt. So put s minus a is equal to u, so that S minus A is equal to P, not U, just you write down like this, is equal to P you write down, so that what you will be getting, substitute here, you will be getting it as integral 0 to infinity e power minus P of t pt, okay, into f of t dt you are getting, right? So this will be what? F of p it is coming, but f of p is equal to what? F of s minus a, na, basically. So this is how your RHS is coming. That simple is your proof. This is the third shifting theorem. So this is a very important theorem. With the help of this theorem, you can get so many things. One example, few examples we can discuss here. What is the value of e power at into t power n is equal to what? This is a question. So first of all, what is L of t power n? Just now we have seen this is gamma n plus 1 upon s power n plus 1, correct? So call it as f of s. So according to the previous theorem, we know that L of e power at into f of t is equal to f of s plus, sorry, s minus s minus a, okay. So accordingly, here f of s is equal to this. So you should replace this one by gamma n plus 1 upon s minus a whole power n plus 1. So this is how the formulas will change accordingly. In this case, f of t is what? So this value will become gamma n plus 1. Wherever s is there, s should be replaced by s minus a whole power n plus 1. So similarly, you have so many formulas you have taken. L of cos at is there, okay, is equal to what? S upon s square minus a square. So this implies L of e power at into cos at will be s minus a upon s minus a the whole square. You can call it as bt. So that it will be s minus a minus b square, correct? So this is how the formula. So you should you will be getting this kind of expression finally using the shifting thing. Like this, all the other remaining formulas also getting changed. Okay, this is all about our this is the first shifting theorem. Okay, I'll get back to the second shifting theorem little later, and a few examples I would like to discuss. So examples based on whatever I have covered so far. Okay, so coming to example number 1, find Laplace transform of L of cos square t. So since we don't have a direct formula for cos square t, using trigonometric operations, cos square t is what? 1 plus cos 2t upon 2. Shall we write like this? Okay. So now using linearity property, half I can take it outside, and I can split and write L of 1 plus L of cos 2t. I can write like this. Okay, this is half into 1 by s, formula already I know, and this formula also I know, s upon s square plus 2 square, that is 4. My job is done. I have done successfully. This is the first problem. So cos square t I have found out. Similarly, the second problem, if L of cos square t is equal to s square plus 2 upon s into s square plus 4, okay, into s square plus 4, then find L of cos square at. They're asking what is the value of L of cos square at. So here we'll apply change of scale property. Change of scale property. What it says, just recall, if L of f of t is equal to f of s, then L of f of at will be 1 by a f of s by a, correct? So this is f of t. If you would have considered cos square t, then this is a f of at only. So accordingly, L of cos square at is equal to 1 by a. So this is your f of s, no? So replace where and all s is there, replace by s by a, correct? Whole square plus 2 upon s by a into s by a whole square plus 4. And you can simplify this to get the final answer. That's all. So this is how you can apply your what is called change of scale property. Then last to find out the third problem, L of t square is equal to what? According to the formula, gamma n plus 1, that is 3 upon s power 3. That is going to 3 factorial upon s cube. That's all, formula substitution only. Okay, but if you're asked L of t power root t, that means what? T power half. So gamma half upon s power half. Gamma is root pi and this is root s. So totally it is root pi by s. So this is how you compute the Laplace transform. Okay. Then fourth example, L of 2 times sine 2t and cos 4t. You have to apply trigonometric properties. This you can write it as sine 2 sine a cos b, formula sine a plus b by 2 cos sine a plus b by 2 plus sine a minus b by 2. If you substitute, finally you will be getting sine 3t, because 2t plus 4t 60 upon 2 3t plus sine minus t, it will come, sine minus t is minus sine t. This is what you are getting. So which is equal to sine 3t is 3 upon s square plus 9 minus this is 1 upon s square plus 1. Formula substitution, a is equal to 1 here, a is equal to 3 here, a upon s square plus a square minus 1. So you can simplify this and you can finalize the answer over here. I think similarly you can carry on the remaining problems. Now there is a concept kind of thing. What is the how existence of Laplace transform? So when a function is given, can you say the Laplace transform of that function is possible or not? So we have a sufficient condition. See, whenever if f of t is sectionally continuous or piecewise continuous, we say piecewise continuous. What is the meaning of piecewise continuous? You see, any function, any curve is continuous between any interval, means there is no break. That is what continuity, graphically if you talk about. And there is a discontinuity, is two types of discontinuity. Between a and b, this is a, this is b, and this is c and d. This is a discontinuity at infinite number of points. But another possibility also is there, discontinuity at look at this problem. This is a, this is b, and the discontinuity at c, single point. There is a break at a single point, and this break we are talking about, see, between a to c totally it is continuous, correct? Between c to b it is totally continuous. Discontinuity at a discrete point, only one single point, that continuity we are calling it as between a to b the function is piecewise continuous. But that means a to c it is continuous and c to b is continuous. This is called piecewise discontinuity. Even then the function is piecewise continuous. So we are able to say the function is Laplace transformation, provided it is if it is a exponential order a. There is another property that this limit as t tends to infinity, e power minus at f of t must exist, or it is a finite quantity, finite. Then these two put together ensures that's a sufficient condition. Means if these conditions are satisfied, then we say that f is f will be Laplace transform of f of t exists. Okay, we say that if this condition holds, then we say but it is not necessary. It's not necessary. Necessary in the sense that uh, if a Laplace transform of a function exists, can we say that these conditions are satisfied? No. For example, I'll consider L of 1 by root t. L of 1 upon root t I'll take. What is the value of this? Achha, in the previous problem, we have handled L of 1 by root t only. Na? You see, this is not, this is 1 upon, because gamma n plus 1, na, this is. So it is wrong. I think we have written it is wrong. This problem we have done it wrong. This is 1 upon root t. That means what? L of t power minus of. That means what? Gamma minus half plus 1 upon s power minus half plus 1. That is equal to gamma half upon gamma s power half. That is going to be pi by s under root. This is how it is coming. So L of 1 by root t, Laplace transform of this quantity is existing. Now come to here. At t is equal to 0, the function is not existing, you know, basically. Put here root t. As t tends to infinity, 1 by root t, f of t is equal to 1 by root t, substitute here. At t is equal to infinity, what happens to here? Or the function is not defined at t is equal to 0. No? So still the Laplace transform is existing. This is one such example where you can find the necessary part is not exist. So if these conditions are conditions holds, then we say that the Laplace transform of the function is possible. Okay, that's why we say that this is the existence theorem. Existence theorem. We term it as. Okay. Now I pass on to the other properties. Now we are in the midway of properties we are discussing. So what happens if derivative of it? What is the Laplace transform of a derivative of a function? Let L of f of t. This is a common slogan you'll come across with every property. L of f of t is equal to f of s, let us assume. Then L of f dash of t, so derivative I am taking, will be equal to s into f of s minus f of 0. So let us see how we can prove this. So proof. I told you, you need not do anything except writing LHS. Simply write LHS. So expand this as per the definition. The definition says L of something means 0 to infinity, e power minus st, I have to write. In the place of f of t, f dash is there. Substitute here f dash t dt. So further you can write it as integral 0 to infinity, e power minus st d of f of t. Right? It is like integral u dv is equal to uv minus integral v du formula. So substitute here u into v. This is u and this is v, correct? So that is e power minus st into f of t, limits 0 to infinity, minus integral 0 to infinity, and your v is f of t, and derivative of e power minus st plus s into e power minus st, correct? dt, correct? So when you put, due to this exponential order, just now existence may, the function is said to be exponential order if this is quantity is finite, provided this function also exponential order for existence. Therefore, this quantity will be a finite quantity. When you put infinity, it will become 0, and then lower limit when you substitute, you will be getting what? Minus f of 0 plus s into, this is nothing but your f of s, correct? And this is not your RHS. Look at that, s into f of s minus f of 0. You got RHS. This simple is your Laplace transform. Okay. So the question is that, sir, okay, we have successfully done this. Can we have a formula for L of f double dash of t? Correct? Is what? That is the question. So for this, what you do is let g of t is equal to f dash of t. So what is g dash of t? Will be f double dash of t, correct? So f double dash of t, you can write it as L of g dash of t, correct? So this is equal to s into g of s minus g of 0, correct? Which you can write it as s into g of s means that is L of g of t, right? Minus g of 0, substitute here 0, f dash of 0 is coming. Further, s into L of g of t is equal to what? F dash of t. F dash of t minus f dash of 0, you can write. This is s into this entire quantity, you can write it as what? Again, the formula you apply, s into f of s minus f of 0 minus f dash of 0. This is s square into f of s minus f of s into f of 0 minus f dash of 0. This is how the formula of L of f double dash of t can be established. Similarly, you can establish f triple dash of t in this fashion, that is s cube f of s minus s square f of 0 minus s into f dash of 0 minus f double dash of 0. This is the formula for third. And similarly, nth derivative, L of nth derivative, even you are given nth derivative, that also formula you can derive just like similar to this, f of s minus s power 1, just binomial form expansion, if you can remember. So dot 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 up to what? Here one order it is less, that is n minus 1 times 0. There it terminates. This is the general formula. You can take this general formula. So this is how you can apply the general formula for the Laplace transform of a particular derivative of a function, basically. Okay. Here in this context, I would like to give an example. Okay, let us see some example over here. What is Laplace transform of sine root t? So for root t, we don't have a formula basically. So what we do is we have a formula for sine x. So accordingly, I can write it as Laplace transform of x, that is root t minus t power 3 by 2 upon 3 factorial plus t power 5 by 2 upon 5 factorial dot dot dot. It will be going like this, okay? And which is equal to, according to linearity property, L of root t minus L of t power 3 by 2 upon 3 factorial plus L of t power 5 by 2 upon 5 factorial minus dot dot dot. You can write like this. And L of root t is equal to what? This you can take half, no, basically. So gamma n plus 1, that is half plus 1, that is 3 by 2 upon s power 3 by 2 minus, this will be gamma 3 by 2 plus 1, 5 by 2 upon s power 5 by 2 and then 3 factorial plus gamma 5 plus 2, 7 by 2 upon 5 factorial into s power 7 by 2. Okay, minus dot dot dot, like this it is going. So this will be, you can take out, of course, gamma root 3 by 2 can be written as half plus 1. Therefore, there is one more formula we can use. So what is that? Gamma n is equal to what? What is that formula? You can recall. Gamma n plus 1 is equal to n gamma n, no? Basically, gamma n plus 1 n gamma n formula. So gamma 3 by 2 can be written as gamma half plus 1, that is half gamma half, that is coming out to be root pi half. Gamma half is pi, root pi upon 2, correct? So this value will be root pi upon 2 times s power 3 by 2, correct? Minus, similarly you can expand this and you'll be getting an expression of this format. You can write it like this. This is root pi upon 2 power s power 3 by 2. You can take it as a common factor. It will be 1 minus 1 upon 2 square into s plus 1 upon 2 factorial into 1 upon 2 square into s the whole square and minus dot dot dot, like this it will go. So finally you can write it as root pi upon 2 times s power 3 by 2 multiplied by e power minus 1 by 4s. You can write like this. So this is the expression you are getting for sine root t. Okay, but the problem is not this is L of sine root t. The problem is not over. You are asked also what is using that. You are asked to find out cos root t, right? It is nothing but cos root t is what? L of sine root t. The derivative, you know, basically you are not also asked this. You are asked like this. What is the value of this? It is d by dt of sine root t. Root t, correct? So what we will get? Sin का cos root t on 2 root t. So 1 2 को add कर लीजिए. So 2 times you can put over here, no, basically. So which is equal to 2 times bracket open. This is s into f of s. This is going to be f of s, na, for sine root t. So that is root pi upon 2 times x cube by 2 e power minus 1 by 4s. Okay, this is f of s minus small f of 0. F of 0. F of t is equal to sine root t. So f of 0 is equal to what? 0. So 0. So this 2 cancels and 1 s has gone. So this is totally pi by s e power minus 1 by 4s. So this is the answer. It's a very important question. See, people will ask this kind of questions only. Why? Generally, I don't know now what is the scenario. The paper setter may be so considerate with you because of corona. Many people may not be having, they may not ask tough questions. That there is a chance they may ask tough questions also, because it involves a lot amount of huge computation, you know, simplification and all these things are involved. So this is how you arrive at this solution. Okay. Well, okay. So now derivative we have seen. Next property is that are you able to follow me? Are you able to get what I am telling? Topic actually this 10 marks, no? Basically each topic is 10 marks weightage, and this is an exclusive topic. 4th unit, 1 unit is based on this. Here there are 3 varieties of problems. The property based, this problems may be asked, any property may be asked. There is a convolution theorem is there, and based on that one problem may be asked, and there is inverse there is a Laplace inverse transform is also is there. Using that also people may be asked. And then application part, what is the very purpose of Laplace transform? You may be asked to solve a differential equation using Laplace transform. That is also, everything is easy. The matter of, I can tell you, if you are familiar with the formulas and properties, hardly 10 to 15 minutes revise, just to recap before the exam. That will do the serve the purpose. All full 10 out of 10 marks you are able to score without any trouble. Okay. Chalo, ठीक है. Let me go to the next topic. That is, we have just now seen what is the derivative of a Laplace transform of a function. Now integral of a function. Okay, next is integral. Remember one more thing. Whatever property you have learned right now, all this property will be getting repeated in case of inverse Laplace transform. There I don't give any proof, because this proof itself will serve as a proof for that also. Double purpose. So therefore ध्यान से सुन लेना, basically just give attention. So as usual, let me take L of f of t is equal to f of s I am taking. Then L of integral of the function, that means 0 to t f of t dt I am taking, will be equal to 1 f of s upon s. So in order to prove this theorem, what I do is, let me consider, let phi of t is equal to 0 to t f of t dt I am taking. Just I am assuming. So this implies phi dash of t will be what? My f of t will come. And phi of 0 is what? 0 to 0 it will come. That is nothing but 0, correct? So L of phi dash of t, correct, is equal to your f of t, correct? L of f of t. correct? Which is nothing but f of s, right? But what is the value of this? The value of this is s into L of phi of t minus phi of 0, correct? And phi of 0 is 0, correct? So therefore, s into L of phi of t will be equal to f of s, or L of, what is this? Integral 0 to t f of t dt is equal to L of phi of t. From this, L of phi of t is what? F of s by. This is what I have to prove, and I have proved comfortably without any trouble. Okay. Here I am not using the so-called LHS RHS concept. Okay. So some techniques differs from problem to problem. So this we have. Then how you are doing with that? What if I am integrating twice? Not once, twice I am integrating. That means what is your question? What is this L of 0 to t, 0 to t f of t dt square? Twice, na? Then f of s. You observe one thing here. When I am integrating, once it will be denominator, I am dividing the f of s by s. If I am differentiating, you might have seen here, differentiating. Okay, I am multiplying the function f of s by s. You might have seen here. See here, I am multiplying. Of course, this quantity is there. Okay, so this is what you have to understand here. So left side, if you are in derivative, you are taking, right side it is a multiplication. Left side, if you are integrating, then right side it is division by s. Okay, same holds. If you are left side, if you are doing a multiplication by t, then it is a derivative on the right side, and it is a division by t, then right hand side integral you have to take. That also we'll see. Okay, so this is all about, just like you can generalize this result by taking a number of times integration. This is not double integration. You see, it is same thing, integrating twice. It is not double integration. Double integration means with the different variables we'll be integrating. Here same with respect to, so it is integration, a successive integration, you can say. This is successive integration. Okay. Then the next property is multiplication by t. So multiplication by t. Okay. So that means what? As usual, any property you begin L of f of t is equal to f of s. This is a slogan you have to follow. Then L of t times f of t. I told when you are multiplying, then you have to differentiate d by ds of f of s. But here one minus sign you have to introduce, that you should remember. Occasion of this n times, if you are multiplying, then you will be getting minus 1 whole power n, nth derivative. What? dt. So differentiate throughout by ds. Since you can take it inside the integral, then there are two variables involved, t and s. So it becomes a partial differentiation. So when you partially differentiate this e power minus st, what you get? Partially, then it will be minus. So this will be minus sign, it will come 0 to infinity. It will be t times e power minus st. Okay, minus st. And that t, I just write it alongside of f of t, so that I can conveniently write this as minus L of t into f of t. Therefore, L of f of t into f of t. T into f of t can be written as, that minus is going that side, and it is d by ds of f of s, or you can write minus f dash of s. And one more t, what will happen? Differentiate once again this, that will be giving you, once again if you differentiate, what will happen? Again it gives you one more t with minus sign. Minus minus plus, then another t square will come. So differentiating n times, you will get this result. This result you will be getting. Okay. So how many times you are multiplying, that many times minus sign multiply you have to do, and that many times you have to take the different derivative. Okay. This is how this theorem will be coming out. Okay. And then it is not ending up with this. There is one more thing is that. Wait 1 second. So there's a simple question. One example I will do so that something you will understand. Okay. Find L of t into sine HAT. So first of all, using this formula, to use this formula, first we must know what is f of s. So as usual, we will find out f of s is what? This is sine AT, which is equal to what? A upon s square minus a square, right? Now according to the formula, therefore this quantity should be minus d by ds of f of s. F of s is what? A by s square minus a square. It will be minus into minus plus s2 a s upon s square minus a square the whole square. Right? Check it. That is the answer. That's all. That simple is this. So whenever you are asked this kind of problems, first find out this quantity. So you may be asked, twisted the question like this. Say for example, you can take it as a homework. Application of several properties. You can take this one, t square e power t sine 4t. So successively you have to apply. So sine 4t, you have what? 4 upon s square plus 16. Then shifting, correct? L of e power t sine 4t. What do you get? 4 upon s minus 1, because the coefficient of t here is 1. Okay, whole power 2 plus 16. So this is now f of s. And now you have to differentiate how many times? Twice ds square of this f of s, that is 4 upon s minus 1 the whole square plus 16. Hope you will complete this. Twice you have to differentiate and give the outcome. So this is the successive application of various known formulas. So first you have to apply shifting and find out what is f of s. Once f of s for this function is known, then apply the formula meant for this. It is, since it is square, minus 1 the whole square, it is plus 1. Therefore, you apply like this and then you try to get the solution like this. This is all about your multiplication by t. So the last property I can say, it is division by t. So that means what? That property itself says what you have to do. Let L of f of t is equal to f of s. Then what is L of f of t by t? So when I am multiplying by t, right hand side I was differentiating. When I am dividing by t, I should do what? I should integrate on the right hand side. So I have to do integration. Similarly, if I am to do more than once, n times, then n times you have to integrate. This is general formula. Okay. So general formula as required, as per the demand, you can go for the general formula. Okay. And this is a simple application. How we are doing this proof. F of s is equal to what? Integral 0 to infinity e power minus st f of t dt. Right? Now integrate this with reference to s to infinity f of s ds. That is, I am taking the RHS. Okay. So s to infinity, 0 to infinity e power minus st f of t dt and ds. Change the order of integration. So you will be getting f of t s to infinity minus st ds and d. Is it correct? ds and dt. And this, if you are integrating, what you will be getting? This quantity will be e power minus st upon t, correct? With a negative sign within the limits s to infinity. Of course, when you put infinity, that will be, put it like this, that will be better. So totally it will come out to be 0 to infinity e power minus st, and this is f of t by t dt, correct? This is nothing but your L of f of t by t, and this your LHS. This is how you prove the result. Okay, these proofs why I am giving on pretext of your examination. You may be asked, explain division property, state and prove division property in context of Laplace or inverse Laplace. Don't at the both the places it may be asked. So the proof remains same in both the cases. So there, how we'll proceed at that time I will tell you. So here, this is how this will be concluded. This is how you have to proceed. And if you give a little thought on this, okay, if you practice, you come to know that it's nothing. It's simple. This Laplace transformation completely, it's a simple task. So what I do is I'll do one problem, and thereby you'll be in a position to solve many other problems also. Okay. Okay. Fine. Number one example. L of sine 2t upon t is what? That is the question. So in such cases, first of all, f of s you have to find out. First thing is, f of s is what? Integral. Sorry, sine. 1 second. This is L of sine 2t, which is equal to 2 upon s square plus 4, correct? This is f of s. Therefore, according to the formula, division by t is what? Integral 0 to s to infinity f of s ds. So, s to infinity, this is 2 upon s square plus 4 ds. This is 1 by 2. 2 cancels. Tan inverse s by a, that is s by 2. Within the limits s to infinity. And tan inverse infinity is what? Pi by 2 minus tan inverse s by 2. This is the answer. That's it. Absolutely no trouble with reference to this. And similarly, you can try various other problems. There are so many problems. You can try this yourself. If I am doing everything, you may not understand how to do the things. So here t square is coming. So t square means what you have to do. You should write like this: 1 minus cos t upon t upon t. Like this you have to take. So 1 minus cos t, see, you can do it in two ways. Either like this, or just you will find out f of s is equal to integral s to infinity. Sorry, you should write it like this. L of 1 minus cos t, that is 1 by s minus cos t के लिए s upon s square plus 1, correct? So what you have to do is here L of 1 minus cos t upon t square, basically. So twice s to infinity. 1 upon s minus s upon s square plus 1 ds into ds, correct? But 1 second, let me. So basically here you will have to do twice. Logarithmic also it will come, basically. See, this is nothing but s to infinity. This is of course log s, and this you can do half. So minus half log s square plus 1 you can write, correct? ds. and this is s to infinity log s upon root s square plus 1 ds. Right, one more integral is coming, and this integral you have to do it by parts. I let formula apply करके simplify करो. You do it something everything मेहनत I cannot do basically. After doing its value comes out to be a big expression. This is coming out to be cot inverse s plus s by 2 log s square upon s square plus 1. This integral you have to integration by parts. Use integration by parts. Then it will simplify to this. It's a tough problem. It's not an easy problem. You see, one t is there, easily it is coming. Second t के लिए once again you have to integrate this logarithmic expression. So again tough procedure is there. Then you can simplify. Finally that comes out to be this expression. Okay.